Okay, welcome everyone. Welcome back to the study season 2024 at TE Academy. Today we are running the second session in Roderick McKinley's program On-Chain Analytics for Token Engineers 101. Become a do-your-own research maxi from scratch using ChatGPT. Yay! And thanks for joining everyone on Zoom. Again, for those of you who are following us on Twitter or on YouTube, you can take part in this study season via registering on tokenengineering.net to get full access to the learning material and the recordings. Plus, you'll have the chance to mint an NFT proof of knowledge for passing or being accepted with a case study in the course of these lectures. More information today in the lecture and in the upcoming sessions. So again, register at tokenengineering.net to get full access. And now let's kick off the second session. We are excited to have you here again. Thanks for joining today, Roderick, and thanks everyone for coming to Zoom or following our stream. Stage is yours.
Thank you so much. Thank you, Angela. Let me know when we're hopefully live without any gremlins. Okay, it's on. Okay, everybody, welcome to day 2. We're going to delve into Dune and smart contracts today. If you're joining now and you enjoy what you see here, I'm an active content creator as well as a consultant, so do feel free to connect on any of these channels that you can see on the screen now. No grand narrative for today's session. We're going to cover a number of areas that are designed to give you understanding and raw materials that are going to equip you for this work. We'll begin with a very brief recap of day 1, a look at the broader on-chain analytics ecosystem, a look into SQL platforms, understanding what makes them special. We'll get a look at Dune and how to use its web app to write queries. We'll then look at 5 places where you can go to track down information about your data tables. And we'll cover some general tips for SQL coding. And then finally, we'll end with a data challenge in advance of the next session. Lots to get through, so let's go. Quick summary of day 1. You can review the lecture online, of course. On-chain analytics and token engineering are often seen as completely separate domains, but they can work together. These 2 activities typically encapsulate contrasting approaches to quantitative modeling. Engineering practices often place a strong reliance on foundational modeling, which defines formal relationships between system parts and how they interact. And this method allows us to build models which give us rich virtual explorations of systems. But the simplifications which we apply in the context of some complex systems can lead to grossly inaccurate models. It's easy to fall into a trap, thinking that just because it has math or it's complicated, that it's right. I can say that because I've fallen down that hole plenty of times myself. Analytics, on the other hand, conducts itself with a more empiricist spirit. It starts off with the data and looks for higher level patterns in variables of interest. And what's cool about this approach is that it allows us to do quantitative modeling without committing ourselves to specific or deep assumptions about how the system works. But the drawback is that these models may lack counterfactual flexibility that you need for deeper engineering, and these models are liable to be caught off guard by new events. We then took a look at exchanges, so how they are critical to almost every token economy. And even though they contain some mechanics which are explicitly mathematical, there are still many complex underlying drivers at work for us to be able to put faith fully in a assumption-driven modeling framework. So 100% foundational approaches are not going to yield the best results, in my opinion. And we need to get and use exchange data to upgrade modeling for our economic systems. So the next important question is, where do we get our blockchain data? In most situations, data collection is a separate process that has to be set up and managed independently. But with blockchains, that's not the case, because blockchains are data. And this is a big part of what makes data economics of this technology so radical and profound. All the properties and operations of blockchains are data-based. And a fundamental feature of blockchain security is the history that these blockchains accumulate, because it is it is because faking the entire history of a blockchain and its cryptographic hashes is hard that we can trust it as a distributed ledger. And so today's blockchains by design make a full history of data available for analysis. In order to apply the same kind of security to smart contracts, a considerable amount of information has to be recorded onto blockchains as well, which means that we also have extended data history about smart contract use on our blockchains. And on top of that, certain smart contracts may also write additional data to the blockchain in this immutable way, which further increases the volume and richness of on-chain data available for analysis. All of this is on-chain data. So something that's actually the hard part of a lot of empirical work, data collection, we get totally for free just because of what a blockchain is. The slightly tricky question that we are faced with now is, how do you get this data out? Well, it turns out that we have quite a few options. I've borrowed this slide from Andrew Hong. More about this absolute legend in a minute. Please don't feel overwhelmed by this. In this course, we are going to lock into just using one specific on-chain data tool, Dune, that you can see right there. And it's really not necessary for you to take in all of this straight away. But I do think it's handy for you to have some awareness that there is an entire ecosystem of activities, services, and tooling in the on-chain analytics space. Perhaps you'll want to come to this again later. Remember, you can download these slides. And as you can see, I've provided QR codes to the source material, including a link to the audio where Andrew breaks this down fully, piece by piece. I want to talk through these first categories a little bit more. But before we do, it's very helpful for you to have some important but often hidden distinctions that apply when we're dealing with on-chain data. What is on-chain data? Well, from a technical perspective, this on-chain data is very broad. It's used not just to refer to the raw data that we find on our blockchains, but also to analysis derived from that same data. It's really important to build awareness of this difference because sometimes the analysis of on-chain data involves arbitrary or contestable assumptions. And this marks some very important differences between the service providers that we saw in the previous table. Some will have offerings that are focus more on the raw or untransformed data, and some might focus on data that has been processed and analyzed to surface insights. Similarly, different services will have different policies about how much you get to see about what was done to the data. So hopefully you appreciate that these differences are important. So let's give ourselves some terms to talk about them more specifically. First, this is a strict definition. I'll explain what I mean by that in a second. First, we have base or raw data. This is the data in its original form. And this is the true matrix code hacker stuff. Humans can't read it. It comes in hexadecimal and other low-level formats, but it's the real deal. And for some kinds of work, that matters. Next, we have decoded data, which translates these low-level data formats into a structured and human-readable form. There's also important and meaningful differences in this category. On the one hand, we have the full comprehensive historical data that's on the whole blockchain, but this time in human-readable form. And then we have data that's been decoded not just to make it human-readable, but to extract and associate all the information that relates to a smart contract or a group of smart contracts that are associated with a particular project. This essentially just filters data from the entire blockchain data set to focus just on the data that relates to a particular project or smart contract. And after that, we have transformed data. This is data that has actually had something done to it. And it's really important to know when this is the case. If we look back at the decoded data, even that data, even though when we're looking at the project level data that's focused on the activities of a specific smart contract, if we apply these definitions strictly, we know that that data is still it's still in its original form. All we have done is filter and structure it so that it is narrowly focused on one activity and nothing else. If we do even the slightest change, say aggregating the data from transaction level to minute level, we have transformed the data. That change is relatively trivial, but in some cases, we end up with value judgments. And it's really important to know what data you're working with. And depending on the work you do, perhaps most of the time you'll prefer to work with data that is untransformed, or at the very least data where you understand any transformations that have been applied exactly and precisely. So these are all very important definitions, but there's a bit of fluidity about how these terms are used in practice. So I'm going to park this as a strict definition, as I highlighted at the top. And what we're going to see now is the common definition. In practice, not many analysts work with the true raw data. So what we end up with is a situation where the decoded full blockchain data is often referred to as the raw data. And the decoded data specifically refers to all that work that's been done to identify the relevant smart contracts and projects, right? So this is what you're going to see very often, and it's what Dune applies as well with their interface. You see that they have a data table called raw blockchain data and decoded projects. Both are human readable, and this is what they mean by it. Okay, so back to this diagram, and just want to zoom into some of these little groupings here. In the index group, the general gist of these services is to get as close to the blockchain as possible. They will serve you the data via dedicated blockchain nodes or forks of blockchains. They also offer special enhancements like indexing, which improve up how quickly you can analyze this data and process it. Some of these services will give you access to the true raw blockchain data. And generally speaking, these services are only going to matter to you when low latency, reliability, and speed are absolutely crucial to your work. In the next group, we have this Explore category, which Andrew uses to collect all kinds of tools which facilitate exploration of a data with less emphasis on performance than the services in the index group, and often leaning more into like graphical user interfaces to support you and help you explore this data without your own super advanced data processing tools. Now, if we fan this out, Andrew actually clusters the exploration tools into two subgroups. Here at the top, these are meaningfully located closer to the index tool group because they are more oriented towards the exploration of low-level, untransformed human-readable data. The prime example of one of these tools that you're likely to have had some experience with as an ordinary blockchain user are the block explorers, like Etherscan. Right? These allow you to enter an address, a transaction hash, and allow you to explore some of the data associated with that point. And we will be using them ourselves as part of this work to check the output of some of our queries. And the second subgroup lean into more sort of higher order value add, even though either they process the data to surface extra insight, or they create dashboards and other graphical user interfaces that empower you to comprehend this data and explore it at a higher level in an easier way. Often this analysis is delivered in a closed way, so you're not able to investigate exactly how they put their charts together or how they got their data. I want to give a quick shout out to Bubble Maps, who are here in the address group. They have a really cool tool for visualizing blockchain activity. And this helps to stress that when you get to sort of downstream end of analytics work, visualization can do a lot of heavy lifting and add tremendous value. And the focus of this tool is actually on understanding human behavior. And that sort of touches on another thing I've observed in the analytics space, which is to say that there's some distinctive orientations between services that are focused on user behavior analytics, like Bubble Maps and Nansen, and we see those guys bundled in the addresses group of this diagram, and those which focus on economic and financial metrics, like Token Terminal, DeFi Llama, Artemis, and we see those guys showing up on the dashboard side of this map because these insights are rarely encoded at the level of the raw data itself. They have to be surfaced by applying financial and economic theory to transform or process the raw data. So there is some distinction between behavioral and economic analytics, but since finance and economic metrics are also the result of human behaviors, ultimately there's going to be some overlap when it comes down to it. Okay, let's pause to take stock. This group is about high performance access to on-chain data. This group is about human readable access and exploration at lower or higher levels. The one thing these two groups have in common is that to some extent they're giving us fixed views on blockchain data. Even though these high-level explorers like Token Terminal and Artemis are incredibly flexible, it's really impressive, that flexibility is still contained by a fixed set of available options. And this now positions us to understand what makes query platforms special. Okay, these platforms have performed some initial work to the raw blockchain data, not just to make it readable in human format, but so that we can interact and work on it using a query language. These languages are specifically designed for retrieving, manipulating, and managing data that has this kind of structured format and allow us to relate various elements to each other. So long story short, on these platforms, there is no limit to the kind of questions that we can ask about the underlying data, except those that are set by the nature of the data itself, or perhaps the computational load of the task. And this is really helpful to us, right? We are still working out what matters in token economics and token engineering. There's no way that we can wait on high-level explorers to give us exactly what we want. So query platforms are designed for us to be able to ask any possible question, even when no one's thought about it before. And as a side note, it's true that in principle, we could get to the same result by pulling the data out of an indexer, remunging it ourselves. But actually, even technically experienced data engineers recognize that it is more efficient to do certain kinds of important work directly on a query platform rather than going through that longer route. So anyway, hopefully you're clear now about what the specific features and value add of these query platforms are and why we would be interested in them as analysts and engineers. So zooming into these query platforms, we have a number of them available. These groupings highlight, group them according to their programming language. These ones here use SQL. These ones here use GraphQL, a language originally developed by Facebook, and the ones on the right use a custom API. I don't know enough to tell you what the truly important differences are, except to say that SQL and many of its variants are older as query languages and the most widely used in the world. As for these SQL options, here are some superficial differences that I've gleaned from the few that I've checked out. I caution that I haven't really done a proper deep dive yet, so best to take these summaries with a pinch of salt. So why did I choose to work with Dune? Well, with all due respect to the team, it was kind of accidental. I came to this task of teaching myself analytics because I was very clear what I wanted to research and study. And when I was looking up how to do that online, I came across some absolutely stellar coaching and learning support published by these two members of the Dune team, Jackie Zhang and Andrew Hong. The course I did was titled 12 Days of Dune. It's from the end of 2022. And some of the code they walk through has depreciated with upgrades that have been made to Dune since. But actually, that can work as a positive for you, since overcoming those depreciations will make you more comfortable with SQL and Dune. And you'll definitely be well positioned to tackle this course after finishing this one. And I highly recommend it. Andrew has his own educational side project as well called Crypto Data Bytes. He's the author of that table we were looking at. Someone else shared a great resource by him. He's obviously incredibly skilled as an analyst, but I also think he's gifted as a teacher and communicator too. So definitely follow him for more advanced and technical content, if only to see how deep the rabbit hole goes. So yes, Dune's brand prominence and the amazing teaching support these guys offered were the reasons why I got started on Dune. Anyhow, back to your SQL options. If you end up wanting to use any of these other offerings, don't worry, because everything you learn here to do with Dune will be very easy to adapt to anywhere else. Okay, it's time now for Dune. Yes, they used to be called Dune Analytics, but they seem to be down with jokes about how this is always going to be the first thing that you see when you type in Dune into a search engine. Okay, here's a link that you can use to sign on. If you're willing to help me out with a small favor, It allows the Dune team to monitor who is using it as a result of this course. It won't push you into any special marketing or spending nudges. It's just so that the team can see whether it's worth building a more formal relationship in the future. I get zero financial value from this, rest assured. Everything that we're going to do on this course can be executed completely on the free tier of Dune. So on to the platform. Some screenshots first. We'll do the live thing in a second. When you log on, this is the page that greets you. And you see that the Discover tab is highlighted. Now, Dune is strongly community driven. And one side of this platform is oriented towards allowing you to explore and expose the work of other Dune wizards or analysts, as they're called. And so that's the experience that greets you when you log in. It's not too hard to work out that part for yourself if it's of interest to you. In this course, I'm going to be focused on the features and experiences related to query creation, visualization, and all that jazz. These two places are where you can go to edit a query, either create query or the library, which stores all your saved queries. So, you would hover over create and select new query. And then this is what you get, the editor console. And that big window there is where you enter your code. And Dune cheerily invites you to type some SQL in here, which for newcomers is going to feel like a bit of a mean joke, because you can know all the SQL in the entire world and still have zero idea what you need to type in here. Because this is the thing about analytics and querying. A lot of people who first sign up to it think that it's really all about the query language or whatever tool you happen to be using. But most of the time, that's not true. The real work is in understanding your data. Speaking from my own experience, I did do a SQL prep course online, but I purposefully didn't spend all my time going all the way to the most advanced levels, because I already knew that I was going to make more practical progress for the work I wanted to do by going directly on Dune and practicing with the actual data. So it may surprise you, nevertheless, that there's still a huge amount of insight that you can get from blockchain data, even if you're just using some relatively basic SQL. And so this innocent invitation here proves the point on all of that. If you don't know what your blockchain tables are called, you can't actually type in anything useful in there at all. So, okay, how are you supposed to discover your table names? And that's where this left-hand panel comes into play. It's called the Data Explorer. We gave it a quick preview when we were looking at differences between raw, decoded, and transformed data. All the data on Dune is in human-readable form. So raw data refers to blockchain data, decoded projects, data that's been filtered and organized at that level. Curated data represents transformed tables prepared by the Dune team. And community data, there at the bottom highlighted one, represents transformed tables that are being prepared by community members. Okay, time to switch to real controls so that you can see me do this live. Let's see. Okay, this is the scary part, people. I have to go here. Okay, can you confirm that Dune is up?
Yes, it is.
Okay, good stuff. So let's get into new query. And oh dear. It's showing the slides again, isn't it? Okay, a second. I didn't test drive this. I thought. Okay, you can see the query again, right?
Yep.
Okay. So let's suppose that I'm a newcomer here. I know enough about blockchain to know that I'm interested in tables that contain data relating to Uniswap v2 for activity that's performed on the Ethereum blockchain, and that I want to get that data in its original untransformed state. So I don't want to look at this raw blockchain data, because that's going to have all kinds of stuff that we don't want. At the same time, I've told you, we don't want the curated or community data here, because these are transformed tables. Where we want to go first, therefore, is the decoded projects category. And we do that, and we get a whole bunch of stuff. There are two options here. We can start typing in, or you can see we've also got an option to filter down by chain. Remember what I said, we're interested in Ethereum, so I can go down here and pick it up. Sometimes the dark mode does some funny stuff, but you should be able to see it better. And so this now is filtered down to schemas that relate to the Ethereum chain. So I can already see Uniswap v2 down here, but I could type in Unis there, and that gives us a much shorter list. Okay, so I know I'm interested in Uniswap 2, so I'm going to click on that. Oh gosh, it's another horrendous list. What is going on here? Well, we're going to explain this. It's I agree. There's no way to know what this is unless someone explains it to you. But we're gonna work through that and explain it a little bit later. For now, just trust me. We're interested in pair, which is one of the smart contracts that Uniswap v2 uses. And then when we get here, we get another list. This is so demotivating, but please, guys, just trust me. It's part of the process. And the more you do this, the more familiar it will become, and the less tortured it will see each time. And we get some more information here. We see that because what we're actually looking at now are tables, and you can see the little table icon, and each of these is labeled either event or function. And this is referenced in the drop-down list. You can filter by event or function. This is going to be really important. So keep that in mind. Actually, let me say something about that now. We don't really need to get into the weeds about the difference between functions and events, but a really sort of helpful starting point is to think of events as bookends to a series of function calls, right? And these events are used in Solidity to record events to the blockchain, and that can include information about lots of data that are critical to the state of the blockchain, okay? So what we're going to do is filter down for event. We're only going to work with event tables in this course. And now, okay, we're left with a shorter list, and I can sort of make out what's going on here. I think I know what a swap is. Mint, I know sort of, conceptually what that is. So I'm feeling a little more relaxed now. I'm not so scared. I was looking for swaps, so maybe they're in the swap table. Let's just, there's a couple of things we can do here. If I click into swap, what this is going to do is it's going to open up a view on all the columns that are in this table, and it gives you the data type there. Cool thing, if I click on this, it does it good. You see that the field name pops into the coding window, which is handy. And if I don't want to be in this view, I can then move up here to this sort of like directory slug, and I'm down in swap, so I can go up one level by clicking on pair here, and I'm back at the table view. And I could also go all the way back through that tree. And so similarly, if I actually click on these double arrows, I get the full name of the table pop into the query window there. And if I look at these ellipses, I can add this to favorites. Is it letting me do that? Preview the table. This is handy. This opens up like a little in tab view of the table for the first 10 rows. You can also do the same thing by opening it up on another tab. Okay. So now that I know what the swap table is, what it's called, which I didn't know before, I can, recreate that very small view. Okay, and click go. Oh no, control and return. Let's go. Dun, 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 dun. And we get the results down there. So that is a walkthrough for how you navigate the Data Explorer to find the names of your data tables. So while I'm here, just want to show you a few more of these features. This is where you code, and sometimes you want that to be as big as possible. So if you click the active icon, that opens it up to the left. You can also expand it down this way. You can also click and drag here, and you can also do Control Shift and F on a PC to get a full screen view. So those are all ways that you can get view. Something that happens with the web app. If you're working with lots of data, sometimes when it loads the query results, it's really slow. So if you click on new visualization, but without following through to do all the rest of the stuff, that removes the query results from the active view, and sometimes that allows you to it makes the web app more responsive if you're doing something that's a little bit more taxing. And you just saw me hit run. I can click the button. I can hit Control Shift Enter. If I click down here, I can choose different engine sizes to run the query faster. On the free tier, you do get some limited medium credits, but you only get large on a paid subscription. Yeah, we're not going to need that for now, but that's where you find that sort of stuff. Something that's very helpful, commenting out lines. So if I were to highlight all of this and click Control Shift and / no, it's just Control and / that rems out or brings back in a multiple lines of code, or just one of them, if that's what you happen to be doing. And there's an autocomplete feature here. If you like that, you can also hit Control Space, which is typical in a lot of IDEs to sort of like get suggested keywords. And yes, perhaps the most important thing, once you have something you like and are happy with, click Save. Okay, always click Save. There's no autosave. Sometimes it handles it. I can't remember what the auto saving thing does, but anyway, just hit save as often as you can to be safe. So I mean, pause for a minute. I fully accept that this may be a little intimidating for some of you, because I was definitely intimidated by it. Not by this code, okay, that's fine, but by having to figure out all of this stuff here. You know, trying to find out what data am I actually interested in, and of course, you know, now the fun business of trying to figure out what the jeepers all this stuff is, right? Because, you know, okay, contract address, but we get some clues, but there's no way we can really know for sure. And as I said before, and as I'll say multiple times, that frustration is totally normal, and it's just part of the growing pains that comes with the process. It's going to come with practice, and ChatGPT won't help you with everything. Dune are working on that sort of guidance and improvement, but you know, it's better to really do this as thoroughly as you can yourself. So I could just sit here and tell you what all this is, but that's not how I want to teach this course. I'm going to help you build up a set of resources and practices that are going to allow you to find out this sort of information for yourself when you need to and when this course is over. Okay, so I think it's back to the slides at this point. So where do you find info on Dune tables? You can go to the Dune community. You can go to the Dune official docs. You can go to the project's official document, the internet, and the Forbidden Archive. Okay, let's walk through each one. Okay, so the first thing you can do is learn from other analysts or wizards. And that brings us back into the Discovery tab here. And, you know, like I said, Dune is super community driven. And you have a lot of work available to you. So, you know, swaps isn't going to bring up anything useful, but I have actually used these features to look into somebody's work and pick up some tips that genuinely did help me. So I've just opened a dashboard here, and you see that if I click into an element, I'll be taken, oh gosh, okay, not this one. This is why I picked one that works. Okay, this is the Dune dashboard by the Dune founder, so it better work. And if we click in on one of these, yes, we get the query, and you can see what he did. Very simple query here. Of course, it's just a very simple result. So, you know, I think you can guess this kind of method is very hit and miss. Until you have some experience under your belt, it's going to be really hard to work out what's right and what isn't. Even if a dashboard's massively popular, you know, you don't really know. But I have used this resource fruitfully. So it's absolutely right that that you're aware of what it can do and that it's there. Okay. Next up, the next place we can look to are the Dune official docs. Let's see. Good. Okay, I have them here. And this stuff's changing. I've certainly seen it change in the last couple of months, or since I started using it. And in its current state, I'd say these docs are good for giving you an overview of how the web app works, how the query engine works, and some high-level insights into the data. Given that, we started this journey looking for information about data, let's click on Data Catalog there, and we get a whole bunch of options here. And so let's start out with Ethereum, because we're looking at the Ethereum chain. We're interested in decoded, so let's go to decoded. And we can go to decoded contracts. And then we get some information. Okay, I'll show you how this works. You can click into column descriptions here, and that opens up another tab. Let's see. And I'm just copying the tab, the name of the table we had a minute ago, right? And here we go. Okay, this is what popped open when I clicked column descriptions. And if I enter in pair event swap, okay, which is the part after oh no, it's the other way around. Okay, so if I enter the part, okay, I've got to do this the right way around. Unfortunately, this table doesn't have anything, so it doesn't show us what we need to do. But in principle, some of the other tables do have information, and we see that's actually the case if we go back to the docs and look up the information on curated data for DEXs. And if we scroll down here, we do see that the column descriptions are populated, and here they do have metadata about some of these tables. It makes sense that the curated data are better documented because they're put together by the Dune team. So you can find some information about them there. The other things, there's other places you can go to to find out more information. Here in curated data in overview at the moment, you have these two references here, the spellbook repository and spellbook docs. Not too long ago, they were calling curated data spellbooks. Part of this sort of wizard brand, magic brand that they're cooking up. So for now, they're still called that here. It's a little confusingly, it's called the abstractions overview, because the idea is when you transform this data, you want to get to some sort of coherent and meaningful idea of what's in that table. It's an abstraction. So that's why that word is being used here. So one of the things we can do is click on Spellbook Docs, and no, here we go. First time I clicked on that, I'll just add I thought it was broken because it takes a long time to open up the web view, but it works. You just have to be patient. And here I've preloaded it to the Uniswap Ethereum folder and then the pair event swap. This is all you can see. There's a lot of stuff here. That's all under the project tab. And here we do have a little bit more information. Ethereum address for the liquidity pool, block number. So we get some information, but we still have a lot of blanks here. So we still don't know what everything is. The other place you can go is the Spellbook repository. This is only if you want to go all the way down the rabbit hole, because it sends you to the GitHub repo. Okay. And if you choose to go this route, you would click into models. That's where they're housing all of their SQL script. And I've already done the digging here essentially, so I know that it's this information on DEX trades is in sector, DEX, and pool readme trades, and then we get to DEX trade SQL, and we actually get some SQL code here, which tells you, if you work through all this stuff, you'll end up at some raw data. And this is, the true diligence and lineage work, the hardcore stuff that will tell you exactly what's been done to the data, if that's ever important to what you're doing. Okay, So let's see what's next. Okay, so I think that's covered it for the Dune docs. In summary, they're helpful for to give you an overview of higher level concepts. The documentation on the decoded tables seems to be a bit hit and miss now, but maybe that will get better over time. And the documentation on the curated data and spells tables is definitely strong or better. And you have the option to go all the way down into the GitHub repo, which is really impressive. Now, I really want to stress here that you can do lots and lots and lots of really cool stuff without ever touching the GitHub repo at all. I'm just showing you where everything is so that you know where to go if you eventually need it. But back to our main mission, we still don't have a complete picture of the decoded table we were looking at. So the next place we look at, if we remember our list, is to do a search for the official documentation. So I've typed in Uniswap v2 docs, and that brings us here. This title doesn't give us much information, but you can see in the slug here that we are in a v2 overview sort of path. And this is the real deal. This is the stuff that Uniswap themselves have put out. So this is really, really important. Right here, immediately, let's see, I think the zoom's a bit too big there. You could start clicking through this, how Uniswap works. There's so much attention and care has been put into these docs. They're really good. So, if you have some spare time, going through all this stuff is really helpful. I'm scrolling the left here, and we can see we've got sections for the V4, V3. We want to be in the V2 protocol for now. Core concepts are interesting here. Advanced topics, guides. And what else was it? Technical reference. No, is it advanced topics? Okay. Well, it's definitely in technical reference and smart contracts. And then this pops out a list here, right? We can see we've got factory, pair, library, router 1, router 2. And I don't know if you remember, I don't blame you if you don't, but actually, where was it? If we go back to our decoded projects, Uniswap v2, great, now this is not running quickly. Sometimes it times out if you've left a tab open for a long while. Give me a second. Pair. Okay. Ethereum. So we see on this list, we've gone into Uniswap v2 as a project, and we've got some stuff here. Pair, router 2, factory, router 01. And if we go back on the docs page, we see that these names line up. So something is beginning to gel. Something's beginning to match. Let's look at the pair contract, which is what I said we were interested in. And I know this just looks like a ton of information, but just don't look, keep your eye at the high level, scanning the headers, and you see we have events and functions. So we have two headers that match up to these important categories we had here, the function and event. So we know this is already helping us to triangulate and find out where the information we need is. And we see, okay, events, mint, burn, swap, sync. If I go back to Dune, mint, sync, swap, they're matching up. So I know I've now found a part of the Uniswap documentation which tells me much more about what's going on. And if I look at the swap variables here, again, back in June, swap. Oh no, that's not. It's that way. You see all the a lot of these variables line up. So, okay, I know that we've done all of this work, and we still don't have an accurate picture of what our smart contract is. But there's more stuff we can do, right? We can do things the old school way and just ask the internet. So, suppose I still don't know what amount zero in, amount zero out are. What the hell is going on here? I don't have time to go through all of this in detail right now. I'm going to try Google search. And the first thing that comes up is Ethereum Stack Exchange. I click on this, and here we go. Amount zero in, amount one in, describe how much was sold and how much was received by the token swap. So that's pretty clear, okay? So these are all resources that we can use. And, there's one more resource, okay? We've gone through 5, and I said that the last one was the Forbidden Archive. And I think you can guess maybe what that archive is. It is indeed ChatGPT. Uniswap has just been so massively successful and popular that in this particular case, we can benefit from the fact that information about the protocol has formed a meaningful part of its status of ChatGPT's training data set. And we can ask it questions. So let's show that here. Here's one I made earlier. I don't know if you still need to do this as ChatGPT gets more advanced, but I'm still priming it to sort of, I don't know if you watched that video I gave you, but this is the way I think about it. This is putting ChatGPT into sort of like a part of the vector space where it's more likely to make probabilistic relations that are correct and meaningful to us. So I'm telling you, okay, be a Uniswap and blockchain expert. And I've posed the human question here. What is the meaning of amount zero in and amount, all the variables in the swap pair contract? And I put that in. Tick, 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 tick. Come on. You were quicker before. My gosh, it's really lazy right now. And ChatGPT has decided to go on holiday. What is going on? Okay, there we go. Okay. And because ChatGPT has this slightly, it has more time on its hands than the real human beings who write responses on Stack Exchange, right? So you actually get a kind of nicely padded, slightly redundant explanation that really sort of helps to cushion and ground your understanding. And, this is absolutely incredible. So why did I call this the Forbidden Archive? Well, it's a very risky source of information. In Uniswap's case, we're very lucky that good data on this subject has been fed to it. But if we're trying to understand smart contracts for ourselves, it's very hard to evaluate this stuff and figuring out whether it's true or whether it's just lying to us. In the next session, we're going to use ChatGPT to help us code, and that's different because I can then read back the code, and provided I have some level of understanding of the of coding, I can interrogate it and assess what it gives back to me, and I can't do that right here. So I have used ChatGPT this way, especially when I was working with Uniswap v3, which is a hell of a lot more complicated. But the way I used it was sort of like to check the rest of the understanding that I'd been building up from these more authoritative sources. It came in at the end just to check that if I wasn't 100% clear on it, that I got it right, okay? So those are the 4 sources that you can use to find out information on your Dune tables. And I completely acknowledge that even with all this work, we still don't have a clear and complete view as to what's in the swap events table. Don't worry, I'm going to give you a clean and focused explanation on what it's about in the next session. That getting to a complete picture was not the point of this exercise. The whole point was to give you a mock-up tour of all the things that you can do for yourself to help you learn about data, because that's one of the key objectives here, is teaching you how to teach yourself, okay? So, next slide. Okay, I want to switch tracks and talk about a few technical tips and issues on the SQL side. We're going to cover Trino style, the flavor of SQL that Dune uses, query efficiency, sense checking in your queries or quality assurance, and sense checking and quality assurance by using explorers. So SQL comes in lots of varieties. They still have SQL in their names because they're similar enough to each other. And Dune uses a flavor called Trino, which was formerly Presto. And I'm going to pretend that I know more than I do and explain all the differences to you. There are a couple of different functions here and there, but ChatGPT is always going to be able to help you out with that. There are no immediate major differences when it comes to coding in Trino from other mainstream styles like Postgres, which is what's typically taught on these online prep courses. And that makes sense, right? Dune would be shooting themselves in the foot if they opted to use a flavor of SQL that was radically different to mainstream varieties. There is, however, one thing I discovered which is an important difference, although it only impacts your work if you start working with much larger volumes or more intensive queries than is typical. And this concerns how CTEs, common table expressions, are handled in Trino. So in PostgreSQL, which is the way I originally learned SQL, CTEs work like a local variable. All CTEs are evaluated and stored in memory. And the advantage of that is that you could refer to the output of this CTE query many times without incurring extra overhead. In Trino, the CTEs run in line. So CTEs are not all evaluated when you run the query, and they're not stored in memory. And every time you reference a CTE, the CTE query runs again. Okay, so this is going to shape the way you program. Personally, I enjoy this way of doing it. Right, you use the CTEs to kind of logically contain different ideas and different data sets and refer to them as and when you need. But if you have large CTEs that are referenced multiple times, then this becomes inefficient. So the general way to work with Trino and Dune is to pass all the accumulated data down a chain of CTEs down to the final query, and only discard data that you're absolutely sure you're not going to need in any downstream queries. That's already a point about query efficiency. And this style means that we can accumulate a lot of data quite quickly. So some tips here are to delay transformations that increase the size of your tables as much as possible. Discard data that you don't need if it's never going to be used downstream. The other thing you can do is materialize queries, which is kind of save the results of that query locally with Dune. And you can see that's one of the options available in this Data Explorer view. The free tier of Dune offers very limited memory for this, but you can play around with it. Two ways to put this to use well is to either materialize a foundational query that you use over and over and over again, or else break up long chains of transformations, preferably at a point where you end up with a table that is conceptually meaningful and coherent. The other context in which performance comes up is when we're building out and testing our query. You don't necessarily need to run it on the entire scope of data that you eventually intend to. Any restrictions on the data that allow you to apply the same kind of logic that you're building and that you're going to perform on the full data set is good enough. So restrict yourself to certain dates, certain wallets, contract addresses, transactions that only deal with one token. It will depend on the data you're working with, what it makes most sense to restrict. By cutting the size of your data down, you'll be able to work through your query as you build it much quicker. Right, sanity checks and quality assurance. I'm going to say something that might ruffle a few feathers. I think analytics is scarier than formal systems modeling, because almost all the work you do in analytics has an exact right answer, and it's relatively straightforward to check. When you make a machinations or CAD model, nobody knows what the results are going to be. The only people who can interrogate your model are other experts who review your code, spot flaws in your assumptions, logic, or coding. In analytics, if you miscode a line that calculates the totals and you end up with double the dollar value that was traded in January, that is flat out incorrect. And people can point that out. This is like doing accounting again. And that's kind of scary. So you have to build up good habits to check your work as you go. I've used graphical analytics platforms that provide you with some added help here by reporting summary statistics as you continue transforming your data, but that's not a part of Dune's offer. So here on the web app, the only way you can sense check your work is by doing it yourself and build a habit of doing it regularly. So because it's much harder to find the causes of errors late in the chain than it is to find them when they first occur. So keep an eye on your sum totals, the counts of your rows, and anytime you perform a change that you anticipate is going to change the size of your table, think ahead about what that change is going to do and sense check afterwards. So if you have, a list of the 12 months of the year and you're going to cross join it with a table that has 4 years in them, that the resulting table is going to have 48 rows, 12 times 4. So double check that immediately after you do the join. That's a trivial example, but obviously it gets a lot more complicated, and you need to keep an eagle eye out because, it's easier to spot the error at the beginning, not at the end. Check for unique values and duplicates. Make sure that they only occur when you expect them to. And if you've generated a new field with an operation, some kind of multiplication or logic, check for null values and make sure that they only occur when you expect them. And perhaps overwrite null values if you're going to perform some kind of arithmetical operations and you want them to be ignored or handled as zeros. Honestly, this is work where I can say that a mild amount of paranoia is a virtue. Overchecking is definitely much better than underchecking. And there's other ways we can check too. Okay, so let's see, we're back on the view here. Is this working? So I've just brought in, when we brought in that query, we got this table, and we actually have like the contract address and event transaction hash. And this is the table that's come up. I can look these up on a conventional blockchain explorer. So let's see if this is going to work like this. So I'm going to put in the hash into this one. And up it comes. And this is where we start sort of, getting a sense for, believing that the data on Dune is real, because we can put any of these hashes into the block explorer and see what comes up. Okay, so what did we have there? Event block sender, amount in, amount out. And we can do that. I'll go back to that in a second. We can do that for the address as well, right? But sometimes it's like a bit onerous to like have to go and grab the string, go into the block explorer, plop it in. So there's actually a really cool thing that Jackie teaches on the 12 Days of Dune course. If you look at the URL, it's a bit small. I don't know how to make it bigger, but it's a very simple structure essentially. It has Etherscan, then it / either TX or address, and then / and it has the value of either the transaction hash or the address. So that's really simple. And what's cool about Dune's platform and maybe this flavor SQL, I don't know exactly how it works, is that you can wrap the values of your hashes in HTML code so that they present as a linkable, clickable hyperlink, and one that opens up a brand new tab. So I've shared the code to do that. That teaches you how to do that in the slides, and they'll be available. So that can cut down some time, and but it's often very important to be able to do this work. Actually, let's see, have I got this? Well, you can see the code up there. I'll share the formal thing. Actually, no, I'm at the last slide. We made it, everybody. So we get to our data challenge. These are the tables that we're going to use for our homework in the next session. And the challenge, if you feel up to it, is to create brief summaries of what the variables in these tables are, because it is by knowing what our data actually is that we can give ChatGPT clear instructions. So the challenge is to find these tables in the Data Explorer, copy the lists of their variable names or column headers, and use some of the things you learned today to write brief summaries about what the variables are. And if you only make it through one table, that's absolutely amazing. So that is the challenge. And with that, it's over to you for questions.
Yay, thanks. This was a pretty straightforward journey to onboard us on Dune. Thanks so much. And I think the homework is quite clear, but let's check. I think, Natish, you've added a couple of comments. Feel free to switch on your mic if you like and ask your question.
Yeah, I did many comments. Sorry about that. While you were presenting, thanks, Rod, for doing that. My last question was more related with the last slide. Like, can you export the results from the query to process them outside? Like, I don't know, Power BI or perhaps other more friendly tool to visualize the.
Yes, but you have to pay.
Oh, really?
Very
okay,
simple
so
answer.
no CSV file to download or something like that. Oh my gosh. Okay.
No, not on this one. You have to check. Let's see. Yeah, no, that's part of the way they're doing it, right? So they're trying to foster as much contribution on the platform by the community as possible. So I was able to do a lot. For me, it was handy to be forced to work in there, because that made me figure out how much I can do with SQL. It's sort of like I had no choice. But eventually, I did hit a wall. I was pulling data for like 5,000 Uniswap v3 pools, and I was performing transformations on them, and I hit the wall. So at that point, I used their API and pulled it out, and I'm now analyzing that stuff in Python. But I've actually pulled it into a Power Query engine and confirmed that the data loads in nicely, and you could do all of that. But yes, that's a limitation. And it's not it doesn't show up badly on Dune at all. I'm not sure there's any data provider that would offer that kind of service for free. That's just too much, right? You're just saying, okay, download everything. They've got to make money somehow. I understand.
Any other questions? Everybody just directly jumped on the homework? Okay, no, go ahead.
Yeah, so I have a question. I'll just introduce myself briefly. I'm Sashant. I work as a tokenomist and consult people here and there. I was wondering, like, because Roderick, you have a huge amount of experience, especially in traditional finance and doing different kind of financial analysis work there. What do you think we can take inspiration from there and bring into blockchain world and provide it as part of tokenomics service and consultation, so that we can give a better perspective to the founders and users and get ourselves as well.
Sorry, would you mind repeating the last bit of your question? I didn't follow you all the way.
Yeah, so I said that because like you have been working in traditional finance, I wanted to understand that what are the best practices and best kind of tools and models that we can bring from there and apply here.
This is a thing. It's so everything. It totally depends on the problem at hand. So, because I have experience in training in finance, I'm positioning myself towards problems where that skill set becomes more valuable. And what I find myself drawn to are issues like treasury management and financial planning, and getting a real clear-eyed view of what the operator, what the core business, what the financial needs of the core business functions are. And so I was drawn to this work to start analyzing liquidity pools and start doing risk analysis and bound things. But what's really interesting, if we go all the way back to that earlier diagram, there are just so many ways in which you can get value from this data. Like I was saying, there's a whole set of tools which are all about understanding what people are doing, and that becomes really important because, unfortunately, a lot of people use this technology to create scams and traps for people. And one of the ways you can sort of show that up is by saying, okay, no, suddenly everybody moved all this money to this wallet, and then they positioned it, and then they fractured it out. And doing that kind of sleuthing is really valuable for some clients. Whereas for others, it just totally depends on the problems you're working on. So yeah, I mean, the other answer to your question is that I'm working it out. It's sort of like a hypothesis in motion. I took some risk management studies because I wanted to think more about how I can add value and what's the closest sort of add-on. But yeah, so I'd say financial planning, an ability to sort of think about metrics that are meaningful to business. So if you've worked in Web 2, things like churn rate, things like average daily users, all of these sorts of things, which we're starting to see become part of the discussion. If you go on platforms like Token Terminal, but also having like the insight to look at the specifics of your token economy and say, okay, there's some risk here of too many players putting too much money in the sink or emitting too much money. So why don't we have like a warning system around that allows us to tweak? It's just gonna depend. So yeah, so I don't have a tidy answer to that, but hopefully there's something helpful in there.
Yeah, I mean, I understand. Thank you so much for that. I mean, just adding one more thing to that. So, as you mentioned, risk mitigation and all those things. So, if that is something which is new for me to explore as something, because my side has mostly been on the side of economics. That is something which I've been working on largely, even in Web3 as well. Like the questions that I dig into that is on economics and crypto economics. So now I want to understand, like, if I have to understand that what are the risks that can be potentially for a protocol or a particular product, how exactly should I navigate through there, and what would you suggest would be a good resource that we should look into for that particular thing to understand?
So in terms of what you could do for yourself, it's if you're a trained economist, you'll have a map of your system, a mental map, a model of your system, and you'll have some sense for what are the conditions which are going to work against the objectives of your economy and what's gonna help it. So risk analysis just begins with that, with exploring where you can push or pull on different parts in a way that's problematic, and then exploring the extreme range of that. Okay, and in the first instance, perhaps that's in a framework that's entirely conceptual, entirely assumptions based. The next level, if you have empirical data, is to try and put those stresses into some kind of context and say, okay, well, actually, we have this market data, so that we know, and we have enough market data to tell us that there's a 90% chance of us seeing a 60% drop in the price or in the liquidity on a given day. So how do we build fund a reserve or create some kind of defense that covers us against that kind of risk? So that's how I would build this out systematically. Now, myself, I'm super paranoid and I guess insecure. So I went and studied a whole program. I studied the financial risk manager certification. But you see, it's a program that's entirely designed for traditional finance and traditional banking. Like the personal, I have had to apply a lot of imagination to my own reading material to say, okay, I can sort of see how maybe I would use this to do that. But this is so new that you're not going to get any really good resources. Gauntlet publish good stuff on risk. I think they're good to look at. Index Co-op published some stuff on risk related to portfolio management, because they essentially build like ETFs and index trackers. Six Man Ventures recently put out an article where they analyzed like lots of airdrops, and that's a kind of risk, right? Essentially, anything that sort of fans out to give you a view of what the spread of possibilities are, and has a data sample that's meaningful enough to inform that, is, has some sort of risk element to it, because you want to do things that are likelier to be better. Nothing's ever assured. So yeah, that's what I've done for myself.
Thank you so much.
Yeah, we have more questions in the chat. I just pick it up. Paulina asks, is a logistical question, is that homework must be ready for the next session on Monday?
This is an optional one. This is not the homework that's going to be graded.
Mhm.
It's an invitation. But the one that's going to be graded is going to be set in the next session. So don't worry. It's I fully appreciate that this is, it's a kind of tall order. But this is it. This is sort of like, there's no easy way around it. You just have to start taking the baby steps as best you can. So I invite you to give it your best shot.
For the calendars, anyways, next Monday is the next session, and the final session will be next Thursday in 1 week. So probably not bad idea to start doing some exercises. Okay. Good, Aaron. I read out your question, but feel free to make any additional comments. Question to you, Roderick, have you tried to incorporate Dune to build trading indicators through API calls?
It's so funny. Anytime I do any analysis, everybody thinks I'm going to use. The first thing that people ask me is when it's going to be applied to trading. I'm doing my analysis from the point of view of treasury management, and there is a test I want to carry out. I want to see whether if I sort of like predict out the ranges of volatility, whether some kind of very simple spending rule outperforms a blind DCA strategy. But that would be done from the Treasury's perspective, not really from trying to create a winning algorithm for myself. But I guess if I spare time, I'll eventually get to that.
Okay, then Victor has raised his hand, and then Sushant, you'll be next. Victor, would you like to ask?
Yes.
Okay.
Can you hear me? Perfect.
Yeah.
Just very, very quickly, two things. One is just if you have any kind of recommendation for how to learn how to decode blockchain data. I don't know if I think we said that we're not going to go through this in this course, but that would be great. And then the second thing is it was just kind of like try to understand your take on how you would go about, for example, if I say I would like to analyze a certain project that has a certain token, but it's a very small project. And then obviously I would like to kind of like look into, I don't know, where is it, a pre-step to kind of just go into Dune, and it would be probably where is it traded the most, like where does it have the biggest trading volume? Because it's great to go on Uniswap, but if it's not a token that trades a lot there, then and then if you had to compare it somehow with smaller and bigger, like a juxtaposition between smaller and bigger projects. The bigger projects might already kind of trade on centralized exchanges that might be, again, a little bit of a different challenge there. Can you kind of give an overview what your, like maybe on a high level, what your process would be in order to kind of say, okay, I would say these 5 steps are the things that I would do immediately, and then I take it from there. That would be very helpful. Thanks.
Cool. Let me try and take that one at a time. So for decoding raw data is outside of my wheelhouse. I know that I'm interested in, arriving at the higher level insights that I'm very comfortable sort of resting on Dune. I use their decoded tables. I don't always use. I avoid using their their transform tables, just because I want to train myself in the habit of using lower level data. What I've done is I've worked with the lower level data, then used their transform data to check that my results are working. But I don't feel the need to go all the way down into decoded data, so I don't know what to tell you. Other than go through Andrew Hong's stuff. He's amazing. Maybe even shoot him a tweet or a DM or something. The other thing you can do is go back to that slide. I'll share the slides immediately after this, and look at those index service providers and go onto their websites, track people down from that community, figure out who they are on Twitter. There's eventually going to be some person who's sharing information, and what these guys are doing is so niche that sometimes they're just, people are happy to share, right? So that's how I would go about sort of working out what to do with all that. Now, in terms of picking up a new token, so you need to know its token address. You need to know its token address. If you know its token address, everything else sort of falls into place. If you could go to the blockchain and then just filter for all transactions involving that token. And then, where Dune comes in handy is some of these interactions are labeled. So you'll be able to work out without having to do the real deep detective work if it is interacting with a Uniswap contract, or if it's going into a centralized exchange unit, so that you get some support there. That's fine when you're starting out. Then you can continue going down the rabbit hole. Where do you find almost everybody who lists a token, who's serious about it, posts it on CoinGecko or CoinMarketCap, and you have to. It's not allowed for you not to. You have to include the token address in order for it to get listed. They do some minimal diligence. So yeah, go CoinGecko or CoinMarketCap, find the address, and then if you don't. If you want to sort of if you don't want to just check directly with Uniswap and you want to go down the chain, that's into the raw. So that would be the raw table in Dune's tables, right? Check out Flipside as an alternative. They're also strongly community driven, but apparently they have bring a more of a curation philosophy to the way they organize their tables. So maybe that will help you sort of move a little bit quicker. I haven't checked in with their community. Got stuck with Dune by accident, and I'm very, very happy with the experience so far. It's been good enough. So I think have I left anything else out?
I think it's pretty much exactly what I do. Thanks. I think it's a confirmation. I can only say what I find specifically challenging is really trying to map, for some smaller projects where maybe the documentation are very agile or difficult to find. It's difficult to kind of without criticizing anything. I know it's difficult because it moves fast, but I just want to say that kind of mapping to what the functions really do, and then try to kind of really understand what is actually happening there. That's sometimes very challenging.
When we get so here's where I think we'll end up, because in the traditional business world, if you're a public company, there are regulations around your disclosures around your financial accounts and that. I'm sure that at some point we're going to get to certain minimal standards of disclosure around smart contract documentation, because it's just too important. If you want to go old movie kind of hacker style, where this ends up is, and you trying to read smart contract bytecode and reverse engineer what the smart contract is doing. There are some people who are doing that kind of crazy stuff. And then there are people on the other side who try and scramble the actions of the smart contract as much as possible. But that's super, for me, relative to where I'm at, that's superhuman stuff. And yes, this is for other smart contracts which everybody uses. We're going to have to up the game, and it just has to be a requirement for people to be able to look at this stuff and know what it does without too much effort. So yeah, fully understand your struggle, man. Good luck.
Thanks.
Let me know.
All right. I think the people are sharing links in the chat. That's great. Love to see it. Anything else you'd like to clarify or add as a comment? Anyone? Okay. In this case, I'd say let's jump on the homework, right? So we'll meet again next Monday. So
That's
there's
right.
time over the weekend, and we'll distribute the slides and the recording on Notion. The Discord channel is open. You feel free to collaborate and work in teams on the homework. You can. How do we submit the homework? Fabi will open Google Drive, and you can drop it there. So just give us some minutes to share all the links on the Notion. And yeah, we'll see and meet each other again on Zoom next week, next Monday, and on Discord if you like. All right.
Awesome.
Thank you so much, Roderick.
Thanks, everyone. Have a great day. Bye-bye.
You too. Bye.
Thanks, man.
Thank you. Bye.
The recording has stopped.